So,
Yes, sir.
yes, great. So, in terms of mechanical vibration, we can say that when a body is displaced from its equilibrium position to its maximum displacement, it attains some energy in the form of strain energy. And when we release forces at the maximum displacement position, the body wants to regain its original size and shape. जैसे ही बॉडी यहाँ पे ओरिजिनल साइज और शेप को रीगेन करती है, while regaining it attains some velocity, right? So here we can say that velocity is zero, but slowly velocity क्या करेगा, increase करेगा, and at maximum position the velocity is maximum, right? Now the thing is कि again at equilibrium position, यहाँ पे जब बॉडी अपना x की वैल्यू जीरो हो गया, जब अपनी बॉडी रीगेन करती है अपनी पोजीशन, तो यहाँ पे प्रॉब्लम क्या आया कि now the body release its strain energy, but this strain energy is again converting into some other form of energy in the form of motion, which is known as a kinetic energy, right? Initially at equilibrium position, then energy level is at the minimum state, but now at again equilibrium position, or you can say that at x is equals to 0, your kinetic energy is maximum. Now again that this body is trying to, this energy is trying to reduce itself, तो ये क्या करेगा कि when it is as a maximum, तो ये अपने आप को फर्दर आगे की तरफ शिफ्ट करेगा. जैसे ही ये अपसाइड मूव करना चालू हुआ, तो ये आपका जो वेलोसिटी है ये अगेन फर्दर डिक्रीज करने लगेगा because of increasing strain energy, right? So at you can say again the maximum displacement position, you can say at the maximum displacement position, the body ज़्यादा displace हुई तो again it stored strain energy, right? When this body again stores strain energy, तो यहाँ पे again आपका velocity is should be zero. When velocity is decreasing and at this maximum position it is to be zero, तो क्या हो जाएगा, maximum strain energy. When you say that the maximum strain energy, then kinetic energy is zero. So you have three different positions. One where maximum displacement, or you can say maximum strain energies happen. One maximum kinetic energy, and one we have where we have a maximum strain. So at the extremes, the energy is at the maximum form, but it is only at the one form. Like at the extreme, we have only strain energy. At the extreme, we have only strain energy, but at the equilibrium, we have only kinetic energy. So this to fro motion continues till it's dissipated. बट अदर कोई एक्सटर्नल फोर्सेस इसमें एक्ट नहीं कर रहा है, तो ये बॉडी हमेशा जो है मूव करता रहेगा. Is that clear to everyone? Is that clear to everyone? So in this diagram also you find, in this particular diagram you find at the maximum position kinetic energy is zero and potential energy is maximum. That strain energy is also a potential energy. At the equilibrium position, you can say the potential energy is maximum, and again at the maximum position, kinetic energy is zero and potential energy is maximum. So you can say that the energy is transferring from one form to another form, and throughout the motion, summation of kinetic energy and potential energy is constant, and it is only changing from one form of energy into other form. Is it clear to everyone? Now I'm going to read this statement. When elastic bodies such as a spring, beam and shafts are displaced from equilibrium position by application of external forces and then released, they execute a vibratory motion. Why they execute a vibratory motion? Because they are performing, or you can say they are changing one form of energy into another form of energy, and this process goes continues. Is it clear to everyone, class? So there is a small statement regarding this. When the body is displaced, the internal forces in the form of elastic or strain energy are present in the body. At release, these forces brings the body to its original position. When the body reaches the equilibrium positions, the whole or elastic or strain energy is converted into kinetic energy, due to which the body continues to move in the opposite direction. The whole of kinetic energy is converted into strain energy, and this process goes on continue and continue. Like once it is converted into kinetic energy, then kinetic energy into strain energy, right? Up to this point, is it clear to everyone, class? Can we move ahead?
Yes, sir.
Great. Now, here in this condition, you can see that what are the terms used in vibratory motion? Let us first understand this term. First one is your periodic motion, a motion which repeats itself after equal interval of time. That is defined as your periodic motion. Time period, the time taken to complete one cycle. Time taken to complete one cycle is defined as a time period. Frequency, number of cycles per unit time. At a simple harmonic motion, SHM, it may be defined as the motion of projection of a projectile moving round in a circle with uniform angular velocity on a diameter. That is defined as your simple harmonic motion. Amplitude, I already explained what is amplitude. The maximum displacement of a vibrating body from its mean position. That equilibrium position, what we said earlier, is also defined as a mean position. These are the terms. Now, I just moving to the types of vibratory motions. So, this type of vibratory motions is defined as, it has been grouped into three categories: longitudinal, torsional, and transverse. Right? Longitudinal means if the body is executing along the axis. So, if this is the axis and your mean position, suppose this is your mean position, and body is executing in this particular fashion, then this is defined as your longitudinal vibration. Torsional vibrations. Torsional vibration is like a twisting movement when we have a torque something. So you can see that this is one of the things, and the body is rotating in this particular. If it is rotating about this axis, right, and then release it, and then release it, and then release it. The body is moving in this to and fro motion. It is defined as a torsional movement. Uh, Transverse. Suppose this is your body. Weight is at the, suppose this is a cantilever beam. This is your longitudinal axis, and this one is your transverse axis. So when body is performing this particular action at this mean position, it is defined as transverse motion, vibratory motion. Is that clear to everyone? This is longitudinal, this one is your torsional, and this one is your transverse, right? Okay. moving to the next section, just read this. The vibration of a system because of its own elastic property is called free vibration. Understand this one. The vibration of a system because of its own elastic properties is defined as a free vibration, or you can say the vibrations of a body. Second point, the vibration which the systems execute under an external periodic force. Under an external periodic force. Under an external periodic force is called as forced vibrations. The frequency of vibration in this case is the same as that of excitation, right? So again, vibration has been categorized in two categories. In two categories, you can say vibration has been categorized in two categories: free vibration and forced vibration, right? In free vibration means the system of its own elastic property. The system of its own elastic property is called as free vibration. Now, what about forced vibrations? The vibrations which executes under an external periodic force. Means there is an external force is acting on the particular body, and its excitation frequency is also same as that of the natural frequency, right? So next define is resonance. Now this term is very important. Now resonance is defined as when the frequency of external force is same as that of the natural frequency, it is known as resonance. It means what? When the external forces frequency matching the natural, or you can say the matching the frequency of the body of the system, is known as resonance. Resonance in simple word is defined as your maximum displacement. Resonance in a maximum terms is defined as a maximum displacement. It means what? अगर हम यहाँ पे समझने की कोशिश करें, if this is your mean position, so it might possible कि your maximum displacement, suppose this is your maximum displacement under certain conditions, but resonance shows its maximum displacement is up to here, right? Under normal conditions, this is your maximum displacement. But when I say it is under resonance, means it matches the frequency of external forces matches the frequency of the internal forces, then it is defined as your resonance. Under resonance conditions, this is defined as your maximum displacement under resonance condition. तो यहाँ पे ये हो सकता है कि आपका कोई बॉडी का टू सर्वाइव और टू सस्टेन this body should attain this maximum displacement, but जैसे ही ये इस point से beyond जाएगा, the body will fail. It means what? कि under resonance condition the system can collapse. मतलब अगर आप देखोगे तो system collapse कर सकता है, and because of that reason you won't believe army cannot march past on a bridge, because bridge itself having own natural frequency. If the frequency of the army march past matches with the frequency of the external of the bridge, then it attains resonance, right? And then maximum displacement can happen, and that can fail the bridge also. Is that clear to everyone, class? What is the meaning of resonance? Resonance means the maximum displacement. Say yes if it is clear to anyone.
Yes, sir.
Yes, sir.
And I believe my voice is clearly audible to everyone, right?
Yes.
Yes or no? Just say loudly. Say loudly.
Yes, yes.
Great. Now damping. The next term that we are going to study is your damping. Damping means the resistance to the motion of vibrating body. If there is no damping, then vibration continues infinitely. To to decrease its amplitude motion and bring the displacements to the mean position, we apply damping system. So damping means what? Resistance to the motion of a vibrating system. Now next term is that is your phase difference. It is the angle between the two rotating vectors representing in a simple motion of same frequency, right? So it is the angle between the two rotating vectors representing simple motion of the same frequency. Now this is one of the examples that vector method of representing harmonic motion. How this is going to be explained with the help of this condition. So here you can say that suppose we are going to define one term. You can say that this is a suppose करो this is your position और ये आपको एक just a minute. Yes. Now see, suppose there is a equation which can say that x sine negative, right? So this is your amplitude and this is your angular position. You can say that. So suppose at omega t positions पे at omega t यानी कि theta at angle theta, your maximum displacement, this is your mean position. You can say mean position at at theta is equals to 0 पे your amplitude x is equals to be 0, right? It means what? At theta you have a particle is having at this particular position. Clear? Now we can say at theta at angle theta, or you can say theta having omega t small x, that is having this of maximum. तो सपोज आपका एक एंगल टर्न होता है और आपका एक पार्टिकल एट दिस पर्टिकुलर पोजीशन पे, ठीक है? तो विथ रिस्पेक्ट टू सर्कुलर टर्म अगर आप देखोगे दिस इज एट द पोजीशन, राइट? ये आपका रोटेट हो रहा है और दिस इज द पोजीशन. So from the mean positions you can say that this is the displacement from the mean position x of a body. Yes or no? जैसे ही अगर आप यहाँ पे ऑब्जर्व करो, आप एट थीटा की वैल्यू 90 डिग्री करोगे तो आपका पार्टिकल यहाँ पे होगा, लेकिन जैसे ही थीटा की वैल्यू अबव 90 डिग्री हुई, ये बॉडी क्या होगा? ये पोजीशन अपनी यहाँ पे होगा. देन आपका वैल्यूज होगा एट थीटा की 180 डिग्री पे दिस पोजीशन, वैल्यू ऑफ डिस्प्लेसमेंट इज हियर, राइट? देन ये आपका होगा व्हेन यू इंक्रीज द वैल्यू ऑफ 180 डिग्री. तो आप क्या ऑब्जर्व कर रहे हो कि योर बॉडी इज बिहेविंग और मूविंग इन अ सर्कुलर पाथ, राइट? बट इमेजिन दिस इज योर डिस्प्लेसमेंट ऑफ द बॉडी, दिस इज योर मेन पोजीशन, ठीक है? आपने बॉडी को डिस्प्लेस किया. So when you displace a body, this will be your maximum displacement point. Yes or no? तो आपका बॉडी पहले डिस्प्लेस किया तो यहाँ पे आया, right? So when it is turning, when you are displacing, or you can say this body is rotating in this particular fashion. At this particular point, this body is at your maximum displacement. लेकिन जैसे ही आप इधर से इधर सब डायरेक्शन में मूव कर रहे हो, your body is returning to its mean position. So at 180 degree again ये mean position पे आ गया, right? फिर ये further move करता है 180 डिग्री से toward 270 डिग्री से, तब तो यहाँ पे 270 डिग्री पे ये आपका further फिर इस position पे आया, right? और यहाँ से फिर अगर आप further move कर रहे हो तो ये आपको फिर initial position पे आ गया. So this is your to and fro motion. This is your to fro motion, right? So it is defined as your linear frequency, correct? And with respect to this, it is defined as your angular frequency. Is that clear to everyone? So ये जो linear frequency है ये आपको f के टर्म्स में डिफाइन होती है और इसको इसकी यूनिट्स हर्ट्ज होती है. ये जो एंगुलर फ्रीक्वेंसी है इसको ओमेगा के टर्म में डिफाइन होता है और उसको बोलते हैं रेडियन पर सेकेंड. And this is x is defined as basically x is your the displacement of a particle. कि x के basis पे is a solution, you can say the solution of the displacement of the particle. Class, is this clear to everyone? Hello.
Yes, sir.
Yes. Anirudh.
Yes, yes, sir.
Okay. And I believe my voice is clearly audible to everyone. Aniket.
Sir.
Okay. So this is one of the solution. This is you can say one of the solution of any equations, right? तो अगर यहाँ पे हम define करें, if we are going to define x, तो x के रिस्पेक्ट में आपका पोजीशन क्या बनता है, दैट इज योर कैपिटल x जो कि मैक्सिमम है. तो यहाँ से यहाँ की जो कैपिटल डिस्टेंस है दैट इज डिफाइन यूजिंग x, राइट? और you can also say that it is also radius of this circle, sin omega t. So when you differentiate dx by dt with respect to time, so what you get, x omega cos omega t, यही मिलेगा. yes or no? cos ओमेगा t को आप क्या लिख सकते हो, x ओमेगा sin ओमेगा t plus pi by. yes or no class, is it clear to everyone? So here in this condition you can see that this is x, your particle having SHM motion support. So x dot is equals to dx by dt, which can be written as x omega cos omega t, or you can also written in this form sin omega t plus pi by 2. It means what? x dot with respect to velocity, with respect to displacement, your velocity is always leading by pi by 2. yes or no? And your velocity amplitude is always x into omega, which is greater than x. Similarly, once we differentiate further with velocity, this is your x double dot, it is defined as your acceleration, right? So acceleration is defined as minus x omega square sin omega t, which is to be written in the form of x omega square sin omega t plus pi. So you can see that acceleration is again leading by pi by 2 with respect to velocity and pi with respect to displacement, and its amplitude is x omega square. So you can find out with the help of this equation, that is your displacement, what is your velocity at particular point, what is your acceleration at particular point, and these are the equations. Is it clear to everyone? Class?
Yes, sir.
Great. So now we are going to understand what is the natural frequency of free longitudinal vibrations and what are the method to find out its frequency, right? So now let's understand natural frequency of free vibrations. Okay, yes. This is a natural frequency of free, you can say longitudinal vibrations. Okay. So here in this condition, the first method that we are going to understand, that is the equilibrium method. In this equilibrium method, we have defined three different diagrams. That is your A, that is your B, this one is your C diagram, right? In the A diagram, the spring is unattached to any of the masses, right? In the B diagram, we have attached a mass M to the spring. Once we have attached a mass, the spring shows initial static deflection, that is your delta ST, that is your static deflection. And under this static deflection, we consider this mass as your mean position. Okay? So now we can say that this body is having some minimum energy state, and at this static position, the body is at its mean position, right? Suppose if we are going to displace a body, if we are going to displace a body at this particular direction, right? So what are the forces at C diagram, at diagram C, what are the forces acting when we displace any body in the downward direction, right? So we consider downward directions as a positive and upward as a negative. So you can see that if at C, if we are going to draw free body diagram at X, suppose this body is accelerating at this downward direction, then what are the forces acting on this particular body? We can see that on this body, a gravitational force mg is acting vertically downward, right? There is an inertia force which is always opposing the motion. So that inertia force magnitude is the mass of the body and acceleration, right? And along with this, there is a forces which is defined as the spring forces. So the spring forces from this position is defined as kx from this mean position. Kx, that is the maximum, you can say, whatever the displacement from the mean position. But it is being displaced from its unstressed position. So here we can write that kx plus delta s t. Okay. So these are the forces which is acting on this particular position of a body, right? So we are going to write an equation which is defined as mg is equals to, suppose this body is, as per the D'Alembert principle, we can say that this body is in dynamic equilibrium condition. And we can write that mg, that the mass vertically downward acting, is equals to inertia force plus the restoring force, that is defined as kx plus delta s. Now this equation can further be written like mx double dot plus kx plus k delta st minus mg is equals to 0, right? Now here in this conditions अगर हम यहाँ पे देखने की कोशिश करें, when the body is at mean position, so there are two forces acting on this. One is the weight, that is defined as a vertical downward acting, and the opposite direction is the restoring force, which is defined as a K delta ST. So we can say that mg is equals to K delta ST, right? And if this is equal to this one, meaning the weight of this is equal to the spring force, then we can also write G by delta ST is equals to K by M. That is another finding, right? So on that basis, suppose this is your equation 1 and this is your equation number 2. On that basis, we can say that mg and minus and k delta st cancel out, and your required equation is mx double dot plus kx equals to 0. So this is the vibratory motion. This is the vibratory motion, or you can say the differential equation of a free longitudinal vibration. When we are comparing this equation with a simple harmonic motion, then a simple harmonic motion can be written as this one, omega n square x equals to 0. So this is your simple harmonic motion essentially. So comparing this equation with the simple harmonic motion equations, we can find that this can be written in one other form, x double dot plus k